Lesson 7. Identifying regions of areas under the normal curve. The area under the standard normal distribution curve can also be thought of as a probability. Remember that in finding probabilities, the following notations will be used. For letter A, this notation means we're going to find the probability at the left of Z. Letter B, this means that we're going to find the probability at the right of Z. Hence, we're going to subtract the probability at the left of Z from 1. Letter C. This notation means that we're going to find the probability of Z that is in between two other Z values, A and B. For notation D, this means that we're going to find the probability at the left of a normal random variable x. For notation E, this means that we're going to find the probability at the right of a normal random variable x. Letter F, this means that we're going to find the probability of a normal random variable x that is in between two other normal random variables denoted by A and B. Let's consider the following examples to understand further. Find the probabilities for each of the following. Letter A. Notice that in the notation, we have the symbol lesser than. So this means that we're going to find the probability at the left of our z-score 1.32. Now remember the rules in finding the area at the left of your z-score. The rule is when you find the area, you will keep the area as is. First, let's find the area associated with our z-score 1.32. So in our z-table, we locate 1.3 on the leftmost side of our z-table, and we have a 0.02 to make it 1.32. So remembering or using the ways on how to find the area where these two values cross is the area of our 1.32. So basically, they cross at 0.9066. So that's the area associated with our z-score 1.32. Remember that the area under the standard normal distribution curve can also be thought of as a probability. Hence, the probability at the left of our z-score 1.32 is the same as its area. And since it is at the left, we keep the area as is. So our probability is 0.9066 or equivalent to 90.66%. Let's go to letter B. Notice that the symbol in this probability notation is greater than. So we're going to find the probability at the right of a z-score negative 1.05. Now let's locate negative 1.05 in our z-table. Basically, it can be found at negative 1.0 on the leftmost corner and 0.05 on the uppermost corner, because 1.0 plus 0.05, that is 1.05. So the area where these two z-scores cross is the area of our z-score negative 1.05, and it is located at 0.1469. Hence, our area is 0.1469. Looking back at our notation, remember that we're going to find the probability at the right of our z-score negative 1.05. So the rule is to subtract our area from 1. So 1 minus 0.1469 is equal to 0.8539. Hence, the probability at the right of negative 1.05 is 0.8539 or 85.39%. Let's proceed to the next notation. This notation right here means that we're going to find the probability in between our z-scores negative 2.15 and 1.25. So first, let's locate the z areas of our z-score negative 2.15 and 1.25. So first, negative 2.15 is found at negative 2.1 and 0.05 in the lines of our z. The area is where these two values cross, and it crosses at 0.0158. Hence, the area of negative 2.15 is 0.0158. Now, let's find the area of our second z-score, 1.25. So, in our z-table, it is located at the positive side. So, 1.25 is at 1.2 and 0.05. So the area is where these two values cross, and they cross at 0.8944. Since we're going to find the probability between two z-scores, we're going to use the third rule. We're going to subtract the z areas obtained from our two z-scores. So subtract the smallest area from the biggest area. So we subtract 0.8944, that's the z area of 1.25, and 0 minus 0.0158, which is the z area of z equals negative 2.15. The answer is 0.8786. Hence, the probability between z-score negative 2.15 and 1.25 is 0.8786, or in percent, it is equivalent to 87.86%. Let's proceed to percentile. For any set of measurements, a percentile or a centile is a point in the distribution such that a given number of cases is below it. So a percentile is a measure of relative standing. It is a descriptive measure of the relationship of a measurement to the rest of the data. For example, in a test of algebra, you got a score of 82, and you want to know how you fared in comparison with your classmates. If your teacher tells you that you scored at the 90th percentile, it means that 90% of the scores of your classmates were lower than yours, which is or lower than 82. And the remaining 10% were higher than your score, that is 82. That's what percentile means. Let's have this example. Find the 89th percentile of a normal curve. So in a normal curve, let's locate where can we find the 89th percentile. The 89th percentile basically means that 89% of the data is below a relative standing 89th. If we want to convert it into area, 89% is equal to 0.8900. Now, using our table of values, let's locate the area 0.8900 so that we can find the z-score of our 89th percentile. We can't really find the area 0.8900 in the table of areas, but we can find 0.8900 between the areas 0.8888 and 0.8907. So the next step is to find the z-score associated with these two areas so that we can identify the z-score of 0.8900. So the z-score of 0.8888 is at 1.22, and the z-score of 0.8907 is at 1.23. By interpolation, let's find the average of these two z-scores. We will just add 1.22 plus 1.23 and then divide it by 2. 1.22 plus 1.23 is equal to 2.45 over 2. Now let's simplify further. 2.45 divided by 2 is equal to 1.225. Hence, the 89th percentile is located at z equals 1.225. Again, this means that 89% of the data lies below z equals 1.225, which is the 89th percentile under the normal curve. That's it for today's lesson. I hope you learned something. Always remember, have a statistic-basing day.